so be aware that you can be recorded while this is going on. If you speak into your mic, your voice will be recorded. All right, thank you. Okay, so the labs. There's two basic labs that are going to be occurring. The first lab we did 6.6. What we did was we took, let me see if I can pin mine. There we go. Okay, so what we did in the first lab, 6.6, is we just took some copper and we heated the heck out of it. All right, so we gave it a lot of heat. Again, if you do have a question at any point, feel free to put it in the chat. All right, now what we're going to do in the next lab is we're simply going to take that test tube full of that brown copper stuff, because if you remember, it changed from red to sort of a blackish brown. I don't have a brown marker, so we use black. All right, and then we put it in a test tube. What we're going to do in this lab is we're going to take that test tube full of brown stuff and we're just going to add a chemical to it. And the chemical we're going to add is hydrochloric acid. The hydrochloric acid will dissolve some things but not others. So we think this might be a mixture of two different things. It might be a mixture of copper and some sort of copper oxide. Okay, so it might be a mixture of an element, copper, and a compound, copper oxide. So when you put more than one thing together and they're just randomly put together, we call it a mixture. So when we put the HCl in, the HCl will possibly dissolve one of these but not the other. HCl will dissolve copper oxide, but it won't dissolve copper. And you'll see that in the demonstration. All right. Now, that's the entirety of lab 6.7, is just adding hydrochloric acid to the copper oxide copper mixture. Now, some of you said that it might not be any copper left in there, and we'll find out. If you see copper when you're done, you know it came back, and it didn't react. And that's lab 6.7. Now, the next piece, lab 7.1, what we're going to do is we're going to take the solution that's made. In other words, what we're going to do is we're going to dissolve the black stuff in hydrochloric acid. Okay, so this will be a solution full of hydrochloric acid, and it's going to have that black stuff dissolved in it. What we're going to do is we're going to add a piece of zinc, or some zinc chunks. And we're going to throw that zinc in there, and you're going to see some chemistry happen. And when you get done with that chemistry happening, what you're going to see is you're going to see something at the bottom of the test tube. So you'll look for that, and you're going to see some color changes and some other things going on. So we're going to do in labs 6.7, we're going to separate a mixture. In lab 7.1, we're going to do real chemistry. There's actually chemistry going to be happening. And you're going to have to look and see what you see that gets produced. So you will see, say, some copper, or some copper-colored stuff at the bottom. And you'll see some other things that will happen. So you're going to look closely at what goes on there. Now, I'm not going to give you the exact details because I want you to think about it as it's going on. All right? So that's the first bit. Now, next bit. Any questions or problems with the lab? That's one of the things that you're going to work on this weekend, is to get those two labs finished. All right. Second thing, we're going to look at chemical reactions. All right. So I'll put that aside for you. And I want you to look. I know some of you the balancing comes easy and it made perfect sense. For some of you it was a little more challenging. That's cool. I'm going to go through very straightforward the basics one more time, and then pick up a couple of specific things, and then we can go from there. And this is really weird because I can't see your facial expressions because I'm recording. But if you have any questions, please again pop in with the chat. All right. All right. So let's take really simple chemistry. We're going to take hydrogen. That's that stuff that was in the tube, the one tube that the guy ignited. And oxygen, that's the one that caused the splint to start to burn again. We put them together and they make water. All right. Now, there is an issue here. First of all, when we see this 2 here, it modifies the thing immediately in front of it. So this is an element. You memorize that to be hydrogen. It says there are 2 of them. There's a 2 here. That says that there are 2 oxygen. There's a 2 here that says there are 2 hydrogen, but only 1 oxygen. If there's no number, it just says that it's an implied 1. It says there's only 1 oxygen. So if we were to draw this, we would have a hydrogen molecule and an oxygen molecule, and they would make Mickey Mouse. Now, over this way or this way? Is that better? Is that better? Yes, no. To the left, okay. Then we got a glare. How's that? Then I got it to the right. Slide to the left, slide to the right. Come on, guys. For my image, it looks bright, kind of smack centered. I can try. Oh yeah, that's true. Thank you. If you haven't pinned my screen, it's awfully small, and it tends to be distorted. Thank you, Connor. That was a huge help. So if you have any trouble pinning the screen, just hover over it, and there'll be a little gray line in the middle, and you should be able to pin it. Yeah, me too, Kyle. I should have told you that. Okay, is everybody better now? And rather, let's say this: is anybody not better now? All right. Okay, now here's the problem. The problem is we've got 2 hydrogen over here, 2 hydrogen over here, 2 oxygen over here, only 1 oxygen over here. You can't start with 2 and end with 1. The other one's got to go somewhere. Okay? Because as chemists, we want to know exactly how many of each thing are in the reaction. We want to know how many of those goes with how many of those to make how much of that. So what we can do to make this work is we can say, rather than making 1 water, we're going to make 2 Mickey Mouse. Because from the 2 oxygen, we can make 2 waters. But how do we symbolize that? What we're going to do is we're going to say, okay, I didn't just make 1 water. I'm going to put a number out here in the front, and that number out here in the front modifies the whole thing. So that says that there are 2 of that molecule, 2 of this whole thing. Again, if I write H2O, that 2 goes to that. But if I write a 2 out here, that says the whole molecule. Now the problem you can immediately see is we now have 4 hydrogen atoms, but only 2 hydrogen atoms represented over here. So what we need to do is not start with 1, but we need to start with 2 hydrogens, 2 hydrogen molecules. So we started with 2 of those, 1 of those, got 2 of those, and now everything's balanced. Now a way that I do that mathematically, and I think she did something similar, is I just do it like this. I go, okay, ignoring the orange for a second, I say how many I check on how many of each type of atom I have, and I say how many hydrogen over there. Ignore the orange for a second, there's 2. Oxygen, there's 2. Ignoring the orange, there's 2 hydrogen but only 1 oxygen. So when I go to balance this, I look and I say, okay, hydrogen, I have the same number, so they're good right now. Oxygen, they're messed up. So what's the smallest thing that goes into both 2 and 1? Well, that's 2. So when I put that orange up there, that says now there are 2 oxygen, but then 2 times 2, there are 4 hydrogen. Okay? And I'm going to use a different color. Well, now the oxygen are good, but the hydrogen aren't balanced, and so I need 2 of this molecule to make there be 4 hydrogen. Okay, anybody questions on that? Okay, I know this is review of the video, but I wanted to start with the absolute basics so we can build from there. Now, a couple of other things to look at. A second example. The question posed is, are we going to be posting this in Schoology? Yes, I will, and I'll explain how once I'm certain that I've actually made it do it correctly, because this will be a new experience, another new thing to try. But I should be able to, yes. All right. Now, let me make up another chemical reaction for you real quickly. Let's say I have aluminum sulfide. Let's see where I am. Am I still on screen? Yeah. Aluminum sulfide plus let's see, about sodium phosphide. Okay, goes to aluminum phosphide plus sodium sulfide. Okay, now I apologize that's not written very well, but I'm in a weird angle, so I'm going to try this. Now, so I'm going to count each type of atom. So I'm going to go through and I'm going to go, okay, I've got aluminum, I've got sulfur, I've got sodium, I've got phosphorus. So now I start to count. Aluminums, 2. Sulfurs, 3. Sodiums, 3. Phosphorus is 1. Aluminum 1, sulfur 1, sodium 2, and phosphorus 1. Okay, nothing's balanced but the phosphoruses. I got the same number of phosphoruses as is on both sides, but everything else is out of whack. So we need to fix that. Sodium's the weirdest. I've got 3 and I've got 2. Well, what's the smallest thing that 3 and 2 both go into? 3 and 2 both go into 6. So what I'm going to do is I'm going to make the number of sodium on both sides 6. Again, I can't change the formula. I have to change the number of them, because this reactant is the reaction that's happening. It's this Na3P thing. So I need to make there be 2 of that whole thing. Now that's going to change a couple things. That's going to change the number of sodium. 2 times 3 is 6. But it also changes the number of phosphoruses, because 2 times 1 is 2. Okay, that fixed half my sodium problem. If I fix the other half of my sodium problem, I'm going to multiply this one by 3. That's going to make there be 6 sodium. But that's also going to make there be 3 sulfurs. Which is nice, because there's 3 sulfurs over here, so there's got to be 3 sulfurs over here. And now we're close, because sulfur's good, sodium's good. I see 2 aluminums, 2 phosphoruses, 1 aluminum, 1 phosphorus. So I'm going to multiply this by 2. Right? If that doesn't make sense, please feel free to ask. Okay. Now, a couple of things else, and then we can stop recording, and then I'll let you get some practice with this. All right? Now, there's some weird things out there where, like, she might have shown you the sulfate thing. I think she showed you that in the video. Now, if I have aluminum sulfate, let's say, this is weird. Let's start with this, sodium sulfate. Sodium sulfate, this thing comes in a package deal where it's all together as one thing. So that says there are 4 oxygens and 1 sulfur, because you don't have a number there, and 2 sodium. Now watch this. This gets a little weird. If I say aluminum sulfate, okay, and that's right in the glare, so let's try that. Aluminum sulfate, okay, 2 modifies the aluminum. But here's the deal. Have you ever seen something like this where it's 3x plus 2? Sure. Seen that in algebra. What do we do with that 3? What's the word we use to describe what we do with that 3? Anybody?
Distribute.
Thank you. Perfect. So we distribute the 3, and this becomes 3x plus 6. Okay? Well, we're going to do the same thing here. Kind of weird. This 3 is outside the parentheses. Let me make this really big so you can see it. Al2SO3. There. That's huge. Now, this 3 is outside the parentheses. So it modifies everything inside the parentheses. So that says that there are 3 of these SO4 things. In other words, what you've got out there, an SO4 is a sulfur with 4 oxygen hooked to it. And I've got 3 of that. So that means that I have got 12 oxygen. And that means that I've got 3 sulfurs, and it still means that I have 2 aluminums. Okay? A little weird, but it'll get easier. Again, this is the beginning. This is a piece of the puzzle. And the reason I'm having you do this particular piece first is because all the other pieces fit into it nicely. All right, so any questions on that? Okay. At this point, I'm going to stop recording, and then we can actually get questions and answers more effectively.